So numerical analysis is a branch of mathematics in which we study various methods or techniques of calculations to find approximate solution of the mathematical problems. So all the methods are only approximate techniques for the solution, and here we can't find the exact solution, and we can obtain the result to the highest degree of accuracy. So here you should know that there are many techniques to find the solutions of different type of problems here, but in numerical analysis we can find only the approximate solution to the highest degree of accuracy, but we can't find exact solution. Sometimes we can't find the exact solution, but we can find the approximate solution which is of the highest degree of accuracy. Now there are many numerical techniques such as the methods to find the solution of algebraic and transcendental equations. So here we study regular falsy method and Newton-Raphson method. So bisection method is not there in your syllabus. So using regular falsy method and Newton-Raphson method, we can find the solutions of algebraic and transcendental equations. Now there are numerical methods to solve system of linear algebraic equations. Those methods are Gauss-Seidel method and relaxation method. So Gauss-Seidel method already people have studied in first sem. So using Gauss-Seidel method we can find the solution of system of linear algebraic equations. Now there are numerical methods to find the largest eigenvalue and the corresponding eigenvector, that is Rayleigh's power method. So this method also you people have already studied in first sem. So using Rayleigh's power method we can find the eigenvalue and its corresponding eigenvector, that is the largest eigenvalue and its corresponding eigenvector. So now we can also implement interpolation and extrapolation concept. There are some of the methods to implement interpolation and extrapolation concepts. So the methods are Newton's forward interpolation formula, that is NFIF, then Newton's backward interpolation formula NBIF, then Newton's divided difference formula NDDF, and Lagrange's interpolation formula, that is LIF. Then we can also do numerical differentiation. Then there are methods to find the values of the definite integrals, that is numerical integration. Those methods are trapezoidal rule, Simpson's 1/3 rule, Simpson's 3/8 rule, and Wedel's rule. So using these methods we can find the we can evaluate definite integrals. So now let us see what is meant by algebraic equation. So algebraic equation means it involves algebraic quantities like x, x square, x cube, etc. Or we can also say that it is an equation which is purely a polynomial in x. That is, for example, x cube minus 2x minus 5 equals 0. So this equation contains only the terms of x. Then second example is x cube plus 5x minus 11 equals 0. Then x power 4 plus x cube equals 80. So all these equations contains only the powers of x. So such equations are called algebraic equations or polynomials in x. Then transcendental equation. So equation which consists trigonometric, hyperbolic, exponential and logarithmic functions are called transcendental equations. So if you see the first example, so x into e power x minus 2 equals 0. So here it contains exponential function, so it is a transcendental equation. So second example, tan x equals x, it contains trigonometric function, so it is also an example of transcendental equation. So in the third example we have x into log x to the base e minus 12 equals 0. So it contains logarithmic function, so it is a transcendental equation. Then fourth example, tan x plus tan hx equals 0. So in this equation it contains both trigonometric as well as hyperbolic function. So this is an example of transcendental equation. So transcendental equation means the equations which consist trigonometric, hyperbolic, exponential and logarithmic functions. Such equations are called transcendental equations. Whereas algebraic equations means it contains only the terms of x, like x, x square, x cube, etc. Now iteration process. In each step the results of the previous step is used and the process is carried out till we get the result up to the desired accuracy. So iteration means, so in each step we are going to use the results of the previous step. Such methods are called, such process is called as iteration process, and the methods which use this iteration process is called as iteration methods. So all the numerical methods are iteration methods, where in each step we use the results of the previous steps. Now let us see what is meant by root of an equation. So algebraically a number a is said to be a root of an equation f of x equals 0 if f of a is equal to 0. Means when you put x equals a, the equation f of x equals 0 should satisfy, when you put x equals a, the equation f of x equals 0 should satisfy. That is, when you put x equals a, the equation should become 0. You should get 0. Then only we can say that a is a root of the function f of x. So let us take an example. F of x equals x square minus x minus 2. Now take f of x equals 0 to find the roots. So x square minus x equals, x square minus x minus 2 equals 0. So x square, we can factorize this equation, x square minus 2x plus x minus 2 equals 0. So x is common from the first two terms, so x minus 2 plus 1 is common from the last two terms, so x minus 2. So x minus 2 of x plus 1 equals 0. So x minus 2 equals 0 and x plus 1 equals 0. So x equals 2 and x equals minus 1. So x equals 2 and x equals minus 1 are the roots of this function. Because when you put f of 2, so here you will get 2 square is 4 minus 2 minus 2. You will get 0. So this x equals 2 is satisfying this function. Means we are getting 0. So x equals 2 is the root. So similarly, if you put x equals minus 1 whole square is 1 minus of minus 1 plus 1 minus 2. So again this is equal to 0. So f equals minus 1 is also a root of the function. Now let us see what is meant by intermediate value property. If there exist two values a and b such that f of x has opposite in signs, say f of a greater than 0 and f of b less than 0. That means greater than 0 means if f of a is positive, less than 0 means f of b is negative. F of a greater than 0 means f of a is positive value. F of b is less than 0 means f of b is negative. So this can be in the reverse process also. If f of a is less than 0, f of b can be greater than 0 also. Then there always exists at least one real root in the interval a comma b. So intermediate value property says that if there exist two values a and b for the function f of x such that they have opposite in signs, that is f of a greater than 0 and f of b less than 0, or f of a less than 0, f of b greater than 0, then there always exists at least one real root in the interval a comma b. So let us see by taking an example. So x cube minus 5x minus 7 equals 0. So here what we do is by inspection method. So here we apply inspection method. Put x equals 0, 1, 2, 3, etc. So if x equals 0, first we take x equals 0. If x equals 0, we get f of 0. F of 0 is 0 cube minus 5 into 0 minus 7. So this is equal to minus 7 less than 0. And if x equals 1, f of 1 is 1 cube minus 5 into 1 minus 7, that is minus 11 less than 0. If x equals 2, f of 2 is, we get 2 cube minus 5 into 2 minus 7. So that is, so adding this we get minus 9 less than 0. And if you put x equals 3, f of 3 is 3 cube minus 5 into 3 minus 7 equals 5 greater than 0. So if you observe the values for x equals 2 and x equals 3, their functional values, that is f of 2 is less than 0, that is less than 0 is negative, minus 9 is negative. And for x equals 3, f of 3 is plus 5 is greater than 0, that is positive. So when x equals 2, f of 2 is less than 0. When x equals 3, f of 3 is 5, which is greater than 0. So that is for x equals 2, we have f of 2 is less than 0. And for x equals 3, f of 3 is greater than 0. So what it implies by intermediate value property? So by intermediate value property, root lies between 2 and 3. So we are going to use this concept in order to find the roots for the algebraic and transcendental equations. So here you are going to study two methods to find the roots. One is regular falsy method and another one is Newton-Raphson method. So the next concept is rounding of errors. So let's say if x is 1.2316792. So if you want to keep the value of x correct to 5 decimal places. So after the decimal point here we have 1, 2, 3, 4, 5, 6, 7. So after the decimal point here there are 7 decimal places, but we have to keep the value of x correct to 5 decimal places. So what we have to do? So in order to keep the value of x correct to 5 decimal places, we have to see the 6th position. In the 6th place we have 9. So in the 6th place we have 9. So and in the 6th place we have 9, but in the 5th place we have 7. So what we have to do? So in the 5th place we have to increase the number by 1. So for 7 we have to add 1. So x becomes 1.23168. So since 9 is greater than 5, so in the 5th place increase the number by 1. So that is 1.2316. So for 7 we have to put 8. So we are adding 1 to the number 7. So similarly, if you want to keep the value of x for 3 decimal places, you have to see the 4th position. So you have to see the 4th place. So in the 4th place we have 6, and 6 is greater than 5. So since 6 is greater than 5, in the 3rd place you have to add plus 1 to the existing number. So x becomes 1.232. So 6 is greater than 5. In the fourth place, 6 is greater than 5. So in the third place, you have to add 1 for the existing number. So x becomes 1.232. So now similarly, if you want to keep the x for 2 decimal places, you have to see the third place. So in the third place, there is 1. So 1 is less than 5. So no need to add plus 1 to the existing number in the second place. So you have to write as it is. So x equals 1.23. So since in the third place it is 1 is less than 5. So no need to add plus 1 to the existing number in the second place. So you can, the number, you can keep it as 1.23. So there are important points to remember. So in the equation, if there is log x to the base 10, always you have to use logarithmic key, log key in the calci. If the equation contains log x to the base a, you have to use ln key, that is ln key. So if the equation contains trigonometric function, then always set the calci mode to radians. So this point is very important point. You have to remember this. So any equation which contains trigonometric functions like sin x, cos x, tan x, always you have to set the calci mode to radians. So this is very important. So now to convert log x to the base 10 to log x to the base e. So we have to convert log x to the base 10 to log x to the base e. So there is a property in logarithm, that is a changing of base property. So that is changing of base property. So we can change the base 10. Here we can change this base 10 to base e by changing the base property. So log x to the base e by log x to the base 10. So both are same. Log x to the base 10 by changing to the base e, we can write log x to the base e by log x to the base 10. Sorry, this is log x to the base e, we are changing to the base e. So log x to the base e by log 10 to the base e. So this is log 10 to the base e. So base is 10, we are changing to base e. So log x to the base 10, we can write log x to the base e by log 10 to the base e. So this is equal to 1 by log 10 to the base e of log x to the base e. So log 1 by log 10 to the base e. So if you type in the calci, we get 0.4343. So log 10 to the base is nothing but, in the calci you have to type ln 10. So ln 10 means this is log x log 10 to the base e. So 1 divided by, so in the calci you have to type 1 divided by ln 10. ln 10 stands for log 10 to the base e. So it gives 0.4343 into log x to the base e. So log x to the base 10 is, log x to the base 10 is 0.4343 into log x to the base e. So you have to remember this.